In this video, I will explore all the different possible sums when you roll two number cubes, both numbered 1 through 4, and then find the sum. So the text says you roll two four-sided dice and find the sum. What is the probability of each sum, and how many different outcomes are possible? So first, to think about this problem, you have two different cubes. Cube 1, which is numbered 1 through 4, and cube 2, which is also numbered 1 through 4. By now, you should be able to recognize there are going to be 6 different possible things that are going to happen. And if you're unsure as to why that is, you might want to review the video probability and combinations. But in short, cube 1 has 4 different possibilities. 1, 2, 3, and 4. And so whatever number you roll with cube 1, let's say you roll a 1, that 1 could be paired with 4 different outcomes in cube 2, a 1, 2, 3, and 4, and so on. So you can make the conclusion that each of the 4 possibilities can be matched with 4 different possibilities. So we can multiply 4 by 4 and have a total of 16 different outcomes. Now, that doesn't help us understand what fraction of the outcomes are each sum. So we're going to work through this table and then discuss how we could find out the percentage likelihood that each sum will be rolled. So I'm going to use a T-chart. Tree diagrams are often used to model this type of a problem. But in a T-chart, I'm going to look at all the possibilities first with cube number 1. With cube number 1, I could roll a 1, a 2, a 3, or a 4. With cube number 2, I could also roll a 1, a 2, a 3, or a 4. So let's find all the possibilities if we roll a 1 with the first cube. If I roll a 1 with the first cube, and then a 1 with cube 2, my sum will be 2. If I roll a 1 and then a 2, my sum will be 3. If I roll a 1 and then a 3, my sum will be 4. And if I roll a 1 and then a 4, my sum will be 5. So far, and we can kind of see this from the beginning too, we could have made the conclusion that our range will range from a minimum of 2 to a maximum of 8, which is a 4 and a 4. So we have a range of 6. If I roll a 2 with cube 1, I can roll a 1, and then I have a 3. So that's my second combination of getting a 3. I could also roll a 4. I could roll a 5, a 2, and then a 3. Or I could roll a 6. I could roll a 3 and a 1, which is a 4. I could roll a 5, a 6, or a 7. And you could probably also look at this diagram as it's being filled out and start seeing a pattern of looking at the sums being diagonal. I could roll a 4 and a 1, which is a 5. I could roll a 6. I could roll a 7. Or I could roll an 8. So, how many different outcomes are possible for 8, 12, 16? What's the probability of each sum? Altogether, though, the outcomes are a 2, a 3, 4, 5, 6, 7, or an 8. Those are the only possibilities that I could roll, but the probability of rolling a 2 is not the same as the probability of rolling a 3 or a 4 or a 5 for that matter. When we look at this board and we see all the outcomes that have 2, of these 16 possible numbers, only one of the 16 is a 2. So we would call this 1/16. If we look at the 3, I have 2/16, and right now I'm going to leave it as the denominator is 16 instead of reducing it to 8, because I really want to focus on the 16 total outcomes, which this denominator is representing. A 4 I have 3 out of 16 possibilities. If I roll a 5, this I have 1, 2, 3, 4 out of 16 chance of rolling a 5. So every 4 times, 4/16 is 1/4. So every 4 times I roll, I'm going to get 1 5 on average. A 6 also goes back to 3/16. A 7 is 2/16. And an 8 is 1/16. I could go ahead and put these into percentages, but to check yourself, I should be able to add up the numerators, and this is why I don't want to put in simplest form, because these should total my 16 possibilities. 1, 3, 6, 10, 13, 15, 16, and the likelihood of each. The most likely outcome is a 4 out of 16, so which is 1/4. So if we were creating odds, we would do it based on these probabilities.